Well, good to see you guys. Well, actually, I can't see you, but I trust you can see me. All right, this is our second lesson in transformations. Last class we dealt with what's called translations. Another word we use for it is a slide, where you take a figure and you just move it around. In terms of ordered pairs, we do left, right, and then up, down. Today we're going to do with a reflection, where you take an object and you just flip it. And we can flip it different ways. The way we're going to do it in this class, it's either going to be up, down, or left, right. It is true you can do them diagonally, but that's really not what we need to be doing in our class here. So I hope you have the notes out. Again, I realize that not everybody may have access to a printer, and I to be honest with you, I don't know what to do about that. All I can say is to do your best to do it on your own paper, and then take a photograph of, whether you've printed it out or whether you do it by hand, upload a photograph for me, and that way you'll get credit for this. Okay, so here we've got a triangle VWU, or however you want to call it, and we're going to reflect it across the x-axis. Now, the first thing I would like you to always do is to mark out what's called your line of reflection. In this case, it happens to be the x-axis, but it's not always going to be. So mark it out. That's your line of reflection. And you're going to reflect this object, this triangle, over that. Now, that may look kind of complicated to you, but actually it's pretty easy. You take one of the vertices and you say, okay, point W is up 1, 2, 3, 4 above. So if I'm going to go across, that means I'm going to come down 4 below for my W prime. So sure enough, 1, 2, 3, 4 below. That's W prime. Point U, 1 unit above, U prime, 1 unit below. And point V is 1, 2, 3, 4, 5 above, so V prime will be 1, 2, 3, 4, 5 below. And then you draw your triangle. And it makes sense, doesn't it? You can sort of picture in your mind, if you were to flip that thing over, boom, it's going to land right there. It's flipped. That's another word we use for a reflection, a flip over the x-axis. All right, let's go to example 2. I think there are 8 problems, if I remember right, on this set of notes. I don't like to give kids tons of notes, as long as I give them key examples, and I expect you to be able to try it on your own, given an example. In fact, that's really the only way to learn math, as far as I can tell, is that you have something already worked out with all the steps shown, and then you cover over the steps with a piece of paper and you try it on your own, or you make up one similar to it and then follow the steps you took. I like the first better in that you're redoing what you just did, where you got the correct answer. You've covered up the way you do it. You tried, did I get the correct answer? Yes, boom, then I can go to the next one. Okay, now, again, this is going to reflect across the y-axis this time. So please mark out your line of reflection. Don't ever forget to do that. Again, that happens to be the y-axis. The line of reflection will shift around depending on the problem. Now, we're going to take this thing and we're going to flip it this way. So, for instance, let's look at point F. Point F is 1 unit above, so come down 1 unit below, and that's F prime. All right, let's look at point G. Oh, you know what? I've messed up. Yep. I was thinking that was the x-axis. Nope, let's try it again. All right, we're flipping it across the y-axis. All right, F is 2 to the left. F prime will be 2 to the right. Point E is 1, 2, 3 to the right. so E prime will be 1, 2, 3 to the left. And G is 1 to the left, so G prime will be 1 to the right. And there you have it. We took that figure and we flopped it over. Now remember from yesterday, the original figure we call a pre-image. The one that we've transformed through a reflection in this case is the image. We start with the pre-image and with the image. Are these isometries? In other words, does the image and the pre-image, are they congruent? Same size, same shape, just different spots? Absolutely. So yes, this is an isometry. Okay, now it gets a little bit different. Not a whole lot, but a little bit more challenging. In this case, we're going to reflect it across the y equals -1 line. Now this is where kids have a problem because they know in their head that, all right, this is the y-axis, all right, that's -1 on the y-axis, right? Okay. Is that -1 on the y-axis? Is that -1 on the y-axis? Ah, so in other words, okay, well that, here I mess up a lot. Fortunately, I catch myself. That's the positive one. All right, where's -1? Down here. Is that -1 on the y-axis? Is that -1? Is that -1? Yeah, so in other words, here is the y equals -1 axis. Okay, now we're going to take this thing, we're going to flip it over. Now, how is point H going to move? It's already on it, isn't it? Okay, so it doesn't move at all. It stays put, sort of like a hinge. It's going to flip over. All right, point I is 1 unit below. I prime will be 1 unit above. Now notice, guys, we're not relating it to the axes. We're relating it only to this line of reflection. All right, J is 2 below, so J prime will be 2 above. H stays put. G is 1, 2, 3 below the line of reflection, so G prime will be 1, 2, 3 above the line of reflection. And there we have it. A mirror image. Boom. All right, next problem. All righty. This figure, four-sided figure, is going to reflect across the y equals +2. Well, where is y equals +2? It's right there, isn't it? Is that where y is +2? Sure. How about that? Is that y is, okay, so in other words, this is y equals +2 line. And so we're going to flip this figure over it. Well, point M and J are already going to stay put. They're right on it anyway. Point L is 2 above. L prime will be 2 below. K is 3 above. K prime will be 3 below. All right. Okie dokie. Couple more. Well, let's see. We're going to reflect this figure across the x equals 3 line. In fact, I might put that in first. We obviously have to plot our points, don't we? But where is x equals 3? All right, that's where 1, that's 2. Is that where x is 3? Okay. Is that x coordinate 3? How about that one, that one, that one? Yes. So in other words, I know because it's going up and down, it confuses students because they think, oh, isn't that the y-axis? No, that's right here. In fact, every point on the y-axis, x is 0. This is where x is 1, x is 2, x is 3. And so that line, every point on that line has an x value of 3. That's why we give it that name. Okay, so let's plot out w, x, y, and z. So we got 2, -4, That's W. X is 1, 1. Y is 3, 0. And Z is 4, negative 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. All right, so it looks kind of like a parallelogram. In fact, probably is. Oops, not too slick, but you got the idea. Okay, now, where are we going to flip it? We're flipping it over that x equals 3 line. So y is already on the right spot, so it's going to stay put. X is 2 to the left, x prime will be 2 to the right. W is 1 to the left, W prime, 1 to the right. Z is 1 to the right, Z prime, 1 to the left. And so there we go. Not too bad. All right, let's do another one. All right, this guy is going to reflect across the y equals negative 1 line. So let's establish where that is. Okay, where on this y-axis is y equal negative 1? Boom. Is that y equal negative 1? That y? Yes. So in other words, here's our line of reflection. Be sure to label it. All right, let's put the original prefigure, Hij. All right, H is negative 1, 2. All right, so there's H. Whoops, not H prime, just H. I is 1, negative 1. J is 3, 1, 2, 3, negative 1. And K is 2, negative 4, 1, 2, 3, 4. Okay, so here's our prefigure. And now we're going to flip it over that y equals negative 1 line. So I and J, I hope it's obvious, they stay put. H is down 1, 2, 3, so H prime will be up 1, 2, 3. K is down 1, 2, 3, K prime will be 1, 2, 3. And I think that did it. Right. And you know, does it look like it's right? Does it look like this flipped over and became that? Sure. All right, now the last two, we're actually being asked to come up with the line of reflection. Again, this is, you know, just, you got to ask yourself, all right, where do you start? Well, the black is the pre-image. How do I know that? Because it does not have the little primes. This one does. So we're saying, okay, this thing flipped over. What line did it flip over? Well, I don't think it takes a genius to think, oh, it was this line. That was that line right there. That's the one equidistant, right? Well, what is that line? Well, that happens to be a reflection over or across the what axis? The y-axis. All righty, let's do our last one. All right, again, take a good look at it. How did we go from pre-image to image? Well, it looks like it flipped right through here, did it not? All right, so let's sketch that line in. Now, what is that line? Well, it goes, what's that spot right there? That's an x equals 1, is it not? Is the x value here a 1? Is the x value there a 1? Is the x value there a 1? Sure. So that's the x equal 1 line, and so you would call that a reflection over the x equals one line. All right, guys, thanks for paying attention.